All right, 10-7, areas of circles and sectors. So, explain how the area of a figure is different from the perimeter. Okay, so area is the measure of the space inside a figure, while perimeter is the distance around the figure. So circle the formula for a parallelogram. A equals base times the height. All right, so this is a parallelogram. A equals base times the height. 3 times 5 is 15. This is 1/2 base times the height, which is 27. And this is base times the height, which is going to be 60. So a sector of a circle is a region bounded by the arc of the circle and 2 radii of the arc's endpoints. So the area of a sector is a fractional part of the entire area of a circle. Okay, so name the arc and the radii of the boundaries of the shaded sector. So the arc is AB, the radii are going to be CA and CB. So name the shaded sector. It will be sector ACB. Okay, the shaded sector is what fractional part of the area of the circle? So it's a fourth, 1/4, okay, because arc AB is a 90 degrees, and 90 degrees divided by 360 degrees equals 1/4. Okay, so 10-11, area of a circle. Area of a circle is pi times r squared. So if I know the radius is 5 feet, then the area is pi times 5 times 5. If the diameter is 1.8 centimeters, then A equals pi times 0.9 times 0.9. All right, so what is the area of a circle wrestling region with a 42-foot diameter? So first thing we do is find the radius. Divide that by half, which is 21. So area equals pi r squared. So area equals pi times 21 squared. 21 squared is 441. Using the calculator, you get 1385.44236, which is approximately 1385 feet squared. All right, how do we find the area of a sector? Well, the area of a sector is just the product of the ratio of the measure of the arc divided by 360 in the area of a circle. So it's the ratio of the area of the circle. All right, so if I know the measure of the arc is 60 degrees, 60 divided by 360 is 1/6. So the area of the sector would be 1/6 pi r squared. So then I do the same thing for 120. I simplify and I get 1/3. So the area would be 1/3 pi r squared. Okay. So what happened here? So a circle has a radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? Read my answer in terms of pi. So what did the student do wrong? Well, it looks like the student did not square the radius. Okay, so what should the student do? So the area of a sector should equal 45/360, that's the fractional part, times pi times 4 squared, which is going to equal 1/8 times pi times 16, which is going to equal 2 pi. So the area of the sector is about 2 pi inches squared. Okay, so how do we find area of a sector, a segment? So all we need to do is, so here is a segment of a circle. Notice we can simply take the area of an entire sector, subtract the triangle formed, and I'm left with the segment. So finding the area of a segment of a circle. All right, so first thing is we find the area of a sector. So it's going to be the fractional part, measure of arc PR divided by 360 times the area. So 90 divided by 360 times pi times 4 squared, and that's going to give me 4 pi. The triangle is a right triangle, so the base is 4, and the height is also 4. So the area of the triangle, A, equals 1/2 base times the height, which is 1/2, 4 times 4, which is going to give me 8. So the area of the shaded sector is going to be 4 pi, area of the sector, minus 8, area of a triangle. And that's actually the answer. On the calculator, we get 4.566370614, which is about 4.6 meters squared. All right, so suppose the sector in circle P has the same area as the sector in circle O. Can you conclude that circle P and circle O have the same area? All right, so let's find the area of sector AOC. So area of sector is going to equal 45 divided by 360 times pi times 8 squared, which is going to be 1/8 times pi times 64, which is 8 pi. Area of sector here is going to equal 180 degrees divided by 360 times pi times 4 squared, which equals 1/2 times pi times 16, which equals 8 pi. Now notice you get the same area of sectors, but do these have the same areas of the circle? Okay, so yes, areas of the sectors are the same. Do the circles have the same area? No. Okay. The circles do not have the same area because their radii are different lengths. And that's the end of this section.